All right, hello everyone. We're going to continue looking at trig functions here. I would say if you didn't already watch the video on trig functions for finding a missing side, I would watch that first. This is kind of the second part of that lesson. So we already have this. Remember, SOHCAHTOA, you use that to set up. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So you have that there. And then, so notice what a trig function does is it relates one angle to two sides. Pythagorean's theorem relates all three sides to each other. And then you could say that memorizing something like a 45, 45, 90, 30, 60, 90, that also relates all three sides to each other based on what angles you have. But the trig functions take one angle and two sides. And as long as you have between those, so you can use two sides to find an angle, or you can use an angle and a side to find whatever missing side you have. That's how they work, right? So it compares two sides to an angle, and you can use any two of those things to find any one that's missing. So what we're going to do here is called inverse trig functions, where we're going to work backwards, and we're going to say if we're given two sides, how can we find the missing angle? So from here, this is across from it, so this would be opposite. And then this is next to it, so this would be adjacent. So what I'm going to do is I'm going to opposite and adjacent, which one of those? That's going to be tangent. So we're going to do tan theta equals opposite over adjacent, so 11.1 over 7.5. Well, I'm sorry, let me go ahead and write it like this. Equals opposite over adjacent, okay? They went ahead and put an x degrees right here. Normally, you'll see a theta instead of x just because a lot of textbooks and softwares like to use Greek letters for angles and then the alphabet we're used to for sides. But in this case, it used x to represent a missing angle, which is fine. So when we plug in what we know, we'll have tan x degrees equals from here, what's the opposite? That was 1.1 over the adjacent, which is 7.5. Okay, so you have tan of x degrees equals 1.1 over 7.5. So what you're trying to figure out here is how can you get x by itself if it's tan of x degrees? So what you're going to do here is what you do is you can get rid of tan and put it on the other side. It's kind of the same way where if you have if it was x plus 2, you could do minus 2 to make it go away. If it was x times 2, you divide by 2 to make it go away. If it was x squared, you take the square root, make it go away. Well, what you can do here to make tangent go away, you'll do what's called tan inverse on the other side. So if tan x equals 1.1 over 7.5, then x degrees basically move tan to the other side, but because it moved over, make it tan inverse, which is this. Notice what I have. I have tan inverse, or tan negative 1 of 1.1 over 7.5. You see that? So if it's tan x equals 1.1 over 7.5, well, to find x, just do tan inverse of 1.1 over 7.5. So what we'll do here, if you look right here, so this is your typical TI-83, and you either have one of these or you could use an online software, which will be similar. So if you look right here, see my fingers right there at tan, okay? Look above it in the yellow, it says tan inverse. The way that works is you press this second button, just press it once, and now any of these numbers you press, instead of the white, whatever's written in white on the actual button, instead you'll do whatever's written in yellow above it. So if I go over here to tan, since I press second, and you'll see it has that little arrow inside the blinking thing, that's because you pressed second. Now when I press tan, instead of tan, it's going to do tan inverse. Do you see that? So look, let me clear this and do it again. So look where my finger is. So if I just press tan, boom, it does normal tan. But if what I do is I press second, where my thumb is, I press that first, second, and now I press tan. Boom, now it does tan inverse, okay? So look at what our problem was. It was tan inverse of 1.1 divided by 7.5. So let's go ahead and do that. Oh, also, always go to mode where my finger is, and make sure that on the third line, you're not in radian, you're in degree mode. So you'd go down 1, 2, go down to that line, and you can go back and forth between radian and degree, and you make sure you select degree. Okay, so we're at tan inverse, and it's going to be 1.1. Okay, I messed up there. Tan inverse, and it's going to be 1.1 divided by 7.5, and we press enter. And we get 8.34, round it to the nearest tenth, so 8.3. 8.3 degrees. That's what our angle is. It's an 8.3 degree angle. Okay, let me pull up one more problem. Let me reset this here. Okay, so now let's do, okay, good. So let's do one that's going to be slightly different. Okay, so for this one, 1467 x degrees. Okay, so look what we have now. We have 1467 x degrees. So from this angle, this is what's next to it, but it's not the hypotenuse, so this is adjacent. Okay, this is adjacent, and over here is hypotenuse. Okay, so we're using adjacent and hypotenuse. That would be cosine is adjacent over hypotenuse. So let's set it up. It's going to be cosine, whatever our angle is adjacent over hypotenuse. So see that when I'm setting up cosine angle is adjacent over hypotenuse. Let's plug in everything. So it's cosine. Our angle right now is just x degrees equals adjacent, which is 14, over hypotenuse, which is 67. And so we have x degrees equals cos inverse 14 over 67. Remember that step, just like we did last time with tangent, we're doing it with cos. It's cos x equals 14 over 67. We'll just make it x equals cos inverse 14 over 67. So you just move the trig function over, and when it moves over, you turn it into inverse on the other side. So let's just go right here. We're going to press second right here. And then we're going to go down and press cosine. So we have cos inverse. And then it's just going to be 14 divided by 67. Press enter. We get 77.93, so just round it 77.9. So the angle right here is 77.9 degrees. One thing I'll say before we finish this is that because you're solving for an angle, you can always double check yourself and make sure the angle you got is reasonable, right? So an angle can only be between 0 and 180 degrees. So if you do it and your angle is like 500, you know you did something wrong. So that's one thing that you can do to help on this. All right, so that's how we do this. This is how you use two sides and use trig functions to find the missing angle.